Okay. Now we are doing the static structural analysis using 3D elements. Using 3D elements, right? So static structural analysis, all we observe the same steps, 7 steps are there. Types of analysis: static structural engineering data, material property, geometry, modeling, that meshing, application of load and boundary conditions, then solution and result viewing result viewing. Okay. So what we'll do, we will import the geometry. So how to import the geometry? uh, Right click, import geometry. You have to browse. Okay. Now suppose already you have .igis file which is being saved, right? You can select that igis file, you can select that igis file and open, right? So it is successfully imported to the FES software. It is successfully imported to the FES software. Else, if you don't have a geometry, you can edit the geometry with, or you can create your own geometry with the design modeler. Yeah. So design modeler you will open, it is similar to the CAD. So you can model here and you can save that file. Okay. So it will consider the geometry as already we have saw. Then model, right click on model, edit, right click on model, edit. So it will open the design modular. It will open the design modular, and whatever the geometry you have imported, suppose it is in the form of connecting rod. It is in the form of connecting rod. Okay. Right. हा काय आहे? कनेक्टिंग रॉड आहे, जी जॉमेट्री आपण इम्पोर्ट केलेली. जॉमेट्री आपण काय केलेली आहे? Import. We have imported that geometry, right? We have units here. Metric units are by default. KPITCs. Suppose you want to change, you can change to the centimeter, meter, mm, whatever. Okay. Material is structural steel. You can observe all this, whatever the property required for the structural steel that are shown here. Okay. Now meshing is under process, it is incomplete, and here for the static structural analysis it is showing question mark, so it is incomplete. It is incomplete. As we move further, we complete by step in this project outline. We will complete each step one by one. Already we have imported the geometry. Already we have considered the imported the material, right? Already here we are considering the coordinate system. So coordinate system x, y, z. Okay. So that is required to know when you are applying the load, in which direction force is being applied. Meshing. So element size. So you can define the element size based on the dimensions of your component. Okay. So I know the component, that's why I am defining the 0.15 meter as a element size. Okay. Then right click on, once you define, right click on meshing, generate mesh. Right click and generate mesh. Okay. Once the mesh is generating, it is showing now it is over completed, check mark. Right, with a green check mark. Under statistics, you observe the number of node and number of elements are being created. Now this is a 3D element which is having a tetrahedron in nature. Okay. In case of beam, a regular cross section, as we have performed that, you get the cubic element, or the element is in the form of brick, cube, similar to the cube. Here you observe all the elements are in the form of tetrahedron. बरोबर है? All the elements, you know the element types, 1D, 2D, 3D. Under 3D, you having a tetrahedron as a element type. Tetrahedron as a element type. Okay. Tetrahedron as a element type. Okay. So tetrahedron is, it is having a 4 corner and 4 faces. 4 corner and 4 faces. That is the tetrahedron. Now under the static structural analysis, just right click on insert. I require to apply, suppose, pressure. Okay. And I also require to constrain the model, so that's why I require the fixed support. I have required the fixed support. Okay, then what will do, I will apply first pressure on edge or on face. So I will select that face, or I will select okay, face, apply, right, and I will select the magnitude of pressure normal to noise. I will select the component. Which component? X component, right? X component. I will select the minus 100 pascal. Okay, so 100 pascal means it is going to act towards the large end. It is going to act toward the large end, right? You can observe here. It is going to act toward the large end. Pressure, which is normal to area, magnitude is minus 100 component. So you can observe here pressure is 100 pascal, its component is minus 100. In which direction we applied? We applied X component, ramp. Okay, fixed support. Now I will constrain somewhere here. I will constrain somewhere here. So I will select the edge fixed support. I will select this with the help of control. I will select the multiple, this lower hole and upper hole. Okay, 7 to 8 edges are being selected. You can select the again one more edge. You can select the again more edge. Okay, now 8 is being selected. I will constrain these holes, right? You can constrain anywhere. You can constrain this face also, this face also. Okay, don't worry. So for sake of understanding only, to apply the boundary condition, we have constraint there. We have constraint there. Okay, this large is going to being what you can say, uh, going to mount on a crank, whatever, crankshaft. Right, so fixed support is being applied. Now solution, what solution is required? You require suppose total deformation, right? Again you require suppose the directional deformation orientation along x. I will keep as it is because the pressure is acting along the x. Then solution, uh, insert suppose stress 1 minus I require, or suppose stress principal stress is required, maximum principal. Okay, then suppose the bending trace is also you require, trace uh, bending trace. Okay, similarly you require suppose strain which strain 1 minus or equivalent. Okay, bending trace geometry. So selection of geometry, bending trace. I will select this as a geometry of a line. This is being selected. uh, it is showing somewhere here. I will delete that. Okay, equivalent strain, and also suppose you require any other types of solution, that is strain energy, amount of strain energy stored. Okay, right. So these are the results that are required after the pre-processing. So you have already defined that. You have fixed support, you apply the pressure. Okay, in model analysis we only apply the fixed support, we don't apply any force. Instead of here force, you can apply the pressure, you can apply the force also, right, or movement also, right? Just you have to right click, insert, right? You have acceleration, you have rotational velocity, you have application of pressure, hydrostatic pressure, force, a remote force is there, bearing load is there, you have bolt penetration, you have movement, you have a line pressure is there, right? You have joint load, right? You have motion load, you have this constraints, right? You have n number of options. Nodal displacement you applied, nodal force you applied on node point. Okay, so n number of options are there. N number of options are there. Now go to the solution, right click solve. So now you can observe it is under processing, and once incomplete it will show the check mark. It will show the check mark. So it is taking some time. You can observe the progress bar here. You can observe the progress bar. Okay, it is taking some time. Right. Now you can observe it is done. And it is all showing the green check marks. Right. So to view the result, you have to only click on total deformation. It is showing some error. I don't know why, but directional deformation obviously it is showing. Okay, when the pressure is being applied, so this connecting rod is going to exposed to some compressive stresses, right? Then equivalent stress you can observe. Then maximum principal stress you observe, equivalent elastic and strain energy store. Okay. So in this way you can observe. In this way you can observe. Total deformation, directional deformation, right? How you can express that in equivalent stress is also there, right? So when at actual it is going to transmit the torque from the piston to the crank, how that going to deform, right? What is the magnitude of trace induced, that you can simulate, okay. So this is very important to know. Now you can observe the equivalent trace, that is 1 mesh trace is magnitude is this 3100 pascal approximately. So it is approximately 3000 means 3 meg kilopascal. Pascal means Newton per meter square. So you have to go for material and you have to check with what is the value of ultimate and yield, right? So ultimate value is and yield value is 2.5 e raised to 8 Pascal. So it is within the limit. It is within the limit. It is not exceeding this value. Once we exceed this value, it is going to the plastic range. Or suppose it will exceed the ultimate value, it is going to fail. So pressure, you can increase the component of pressure. Okay, instead of going to one, suppose 1000 dila 100 of that, instead of going to 1000, again I will solve. And you can observe the magnitude of stress equivalent to 1 minus stress. So equivalent 1 minus stress. You can observe now. This is now 30,000. 30,000. So 3 into 30 into 10 raised to 3. So it is within the limit of material, within the limit of material, right? So it is 30,000. This is not nothing but the 2.5 into 10 raised to 8 Pascal, or in case of 25 megapascal. So it is within the limit 2500 Pascal megapascal. So which is within the elastic limit or yield limit, right? So whatever the pressure we are going to exposing, applying on that connecting rod, that are going to sustain or that is taken effectively by this connecting rod. Okay, because dimension is very large. Dimension of this connecting rod is very large, right? Around 5 meters or more than 5 meters are there. This is very large connecting rod. So it can able to take whatever the force is being applied. So you can observe the other values also. What is the amount of strain energy which is stored? Application of paper. What is the strain energy? Amount of energy stored within the elastic limit. Within the elastic limit. So this is the strain energy, and it is showing over the element. Over the element. Okay. So in this way, you can do the model analysis. So sorry, static structural analysis. In this way, and take whatever the input is there. From this idea, you can get what is the deformation is there, what is the amount of total deformation. So it is a e raised to minus 8 m meter. So it is very small value, micron value आहे mm मध्ये, or meter मध्ये तुम्ही calculate केलं, it is micron, very small value. Right, so this deformation can be also taken. You can find the amount of deformation which is produced by the application of force. Okay.